applause for Michael.
Thank you, thank you. I'll try to keep my range of walking. Normally I walk a little bit more. Today I feel restricted, but it's okay. There is a problem with my beamer. Can somebody help me with that? Why should we test it front off, right? We have time while they talk. So maybe I give you a little bit of intro while my beamer is fixed. The talk is about Angular specific problems. I tried to pick out the ones that if you catch them in your project, you can fix them easily. But in general, it is applicable to nearly all other frameworks, at least the majority of the stuff. And as my beamer is fixed now, I will start. And I'm not sure if you know about the project Movies, the Movies apps. Maybe, maybe not. So I will introduce it a little bit. There is an Angular version of the Movies app. You have the link here, and I will explain later about the Angular specific version, but let's talk with all versions at all. And there's a really, really cool and interesting project inside of Google that's called Aurora. And this project is all about improving the existing open source tools, libs, frameworks to get faster. So they contribute not to their own code base, but to other code bases. It's exciting. I don't want to know how to justify that to my boss, but I love that they do it. It's led by Eddie Osmani. And he asked the performance lead for the Angular team, hey, can we maybe do an Angular version of that stuff? So Minko, responsible for that in the Angular team, reached out, and I had the pleasure to write the Movies implementation for the Angular version with our company. We took over a very old version of the website. It was 49 points in the Lighthouse score. Not sure how much the Lighthouse score counts for you, but it is an acceptable measure. And we brought it a couple, like I say, it's already a year ago, to 99. Today, with some improvements, and Cloudflare we have 100. But this is the first version of the improvement. That's the before and after GIF. On the left side, so you see 2.3 seconds, then it grayed out. On the right side, it is still running while I'm talking, 7.1 seconds. It's slow. If you want to compare it and wonder which is the fastest framework out there, Angular was first, really 2.2, amazing. Okay, so the Angular, at the moment, the Angular version is the fastest in the movie set. I'm still searching for somebody that helps me with the next part to align it visually. If you're interested, we can talk. My name is Michael Hladky. My last name is very hard to read, write, and pronounce in most of the countries in Europe, so we can stick with Michael. And yeah, I want to tell you a couple of tricks. The first one, I want to show you how to introduce largest contentful paint optimizations. And I will focus on Angular versions 15 on and upwards because they shipped quite some really nice tricks there. Let's first start with the LCP breakdown. Here you see 4 different phases that it takes the browser to render your largest contentful paint. This methodology is also generated by Google. I don't really know who made it, but it is amazing, right? It helps you to look at that measure, and you have 4 sections, and the 4 sections are well explained, and you can understand where you can do stuff. On the very left side, right side, when you look at the screen, you have SSR, server-side rendering. Scope, you can use server-side rendering, and the technology is there to improve this part, the time to first byte. Then you have the framework section, resource loading delay, the time it takes until your largest contentful paint loads. Then you have the resource load time. This is really the time that it takes to ship this specific image, this specific data object, and at the end you have browser rendering. And for all those 4 sections, I can give you a couple of tricks. Let's start with SSR and LCP. If you want to turn on server-side rendering or client-side hydration, however you want to look at that problem, it's one line. Angular did really nice improvements, and today it is one single line that you need to move in, and then you have it out of the box. Out of the box with not only server-side rendering, but you also have non-destructive hydration since recently, and they also do a couple of cool things. They inline your critical CSS and so on. So Angular is really decent in that, and yeah, I can only compliment the team. By turning that on, we can move this acronym here, CSR, client-side render delay. We can remove that completely. We can perform all that work at the server, and when we're done, we ship it, and the user will see immediately some visual feedback. A little bit more detail, we can not only render the HTML, what we can do if we fetch data on the server, we can also understand, do we need the data too on the client? Was it just useful on the server? And if it is helpful for you on the client, you can also add this data to your transfer state. So you basically transfer the data in form of a JSON structure from the server to the client, and you don't rerun that HTTP request a second time. Pretty much valid for nearly any framework. I have the Build.io guys here in the front row, so I'm very careful of saying any frameworks. I should always say pretty much any. Yeah. Okay. In version 15, there was a ugly piece of code in Angular that you basically ship the server-side rendered page, and then it deletes everything, all the DOM nodes, it redraws it again. So it's not really a hydration, it was a kill all and restart, Microsoft style. Oh, sorry, that was an old Microsoft style. Today we are like open sources, Microsoft. So it destructed all the DOM nodes, it regenerated all the JavaScript objects, and then it redrew the page, and that was this ugly white flash here that I marked. It was not good. It caused CLS and other problems. And the Angular team fixed that. I was very happy. Today it looks like this. It's beautiful. Let me go back and forth. Oh. Ah, nice, huh? Yeah, so this improvement was decent. It speeded up the LCP also by a couple of milliseconds, like relevant numbers. Pretty cool. And it's out of the box. It's nothing that you need to really add. It just works from version 16 on. If you want to do more with server-side rendering, a coworker of mine, Enea, wrote a library, ISR, incremental static site regeneration. It helps you basically to cache and do other regeneration things on the server side. You can go a little bit more complex. The YouTube link to the videos here, the repository is called RxAngular, the package is called RxAngular/ISR. Okay, Angular has a couple of other optimizations. The Aurora team, and I believe I don't even know who wrote it there, but one of the members in the Aurora team wrote the NgOptimizedImage package that helps you also with a couple of tricks when you deal with images. Very helpful. At the beginning I was like, nah, 8 kilobytes, I could just add the lazy loading tag on my own, but no, it's not only the lazy loading tag, it's a couple of other things, so in the end it pays off and you're happy to pay the fee of 8 or less kilobytes. So what can you do? You have a directive that is called ngSource, and this ngSource directive does a couple of things for you. It adds the lazy loading attribute to all the images automatically. So by default, all your images are lazy loaded, and you can specify which of your images is important, and then you can flag it. You can put fetch priority high there, and then it will help you to ship that in a very good way. It also, when you have server-side rendering on, it pre-connects to that domain if you have a CDN that ships your images. it happily does that for you automatically and you don't need to think about it. You can do more. If you worked with images, there is also the src set. Pretty cool for responsive images. You can use that on a picture tag or an image tag. You can specify versions of your image. The versions can map to the screen size. The version can map to the pixel ratio. Any metric that you can basically derive from the client that helps you to specify a more appropriate image, format, image size, and so on. You can save a lot of bytes and you can improve a lot. What do they use? They help you by pre-connecting to that domain. So you basically run your Angular application, they understand what images are fetched from which domain, and they will add the pre-connect tag to the top of your HTML meta tag. That's cool. Why? Because you don't need to wait until your image is fetched to connect to the specific domain. It does it automatically at the beginning, and if you use it later on, it helps you and you can save some time. If you don't use the image later on, better don't put pre-connect there. Lazy loading. I guess you know a little bit about lazy loading. I will give you a quick demo later. But you basically can put the loading attribute on two different tags, on an image and on an iframe. And I'm on it to also convince the standard team to put it on the SVG, at least for some sub-branches of that. It would help. And you can have two values. You can have lazy and eager. And eager is what we all are used to. You have an image there, you put it in your DOM, boom, browser fetches it immediately with a very high priority. If you put lazy there, nothing really happens. If the screen is visible in the screen, the browser will fetch it, but with a very low priority. This lazy loading was already here, and it was really helpful since a couple of years now, but there were always these edge cases, and you try to do your best to tell the browser which image is more important and which is less important, and it was a clutter. Not today, because today we have fetch priority, and this is a really cool feature. I love it. Anywhere in your HTML, may it be a link, directly the image tag or an iframe or whatever, you can put fetch priority there. You have high and low, and this basically gets recognized by the pre-screen parser, and it will prioritize your image automatically, however you specified it here, and you don't need to add a second preload, prefetch. All the old tags that we had to do before, basically, they are gone. You can delete all of them. You just have this one tag, fetch priority, and your code will be more maintainable also, because you don't always need to go to the top of your index HTML and add something. Just put it on any element, it will work. Wonderful. There are responsive images and RSC set. This is a cool feature, pretty tricky to implement. You read the docs, it makes total sense to you. You write your snippet of HTML, you test it, and then you're like confused because it's not doing what you assume. Or at least my implementations did not do that, so I spent a lot of time to debug that stuff, and at the end I was like, fox it, I write a script to debug it, so I will show you how to debug and use that today. Quickly, you can do it on an image, you can do it on a picture tag. I showed you that already before. And I go straight to the demo. So here is a movies app. Let me full screen that thing. And if I open up the wonderful Chrome DevTools and I refresh my page, I have to say that, by the way. I have to say that they're wonderful. And if I refresh the page and I go for images, you see all the images that are fetched on that page, and if I clean that up and I scroll down, you see more images are loaded the more I scroll down. So there is a threshold that basically tells the browser if your image gets closer to the viewport. This is the visual part of the screen, the pixels that you can see. If you go closer to that, you will automatically fetch that image. If it is too much outside of your viewport, it will not get loaded at all. That's wonderful, and it is very quickly to implement, very easy. Now back to the source set. Lazy loading images is not that cool anymore, I would say, nowadays. It's just good to remember it. So we have that image here, and if you can imagine, if I'm on a mobile phone, it's a very small image. If I'm on a tablet, it is a little bit bigger. And if I'm on a desktop, it is medium size. So it would be best that I can tell my client which version of the image, which size of the image it should fetch. And this is what you can do with source set. You can read up the docs. The only thing that I want to show you is how to debug that, because this is, I lost a lot of lifetime when understanding how it works and what I do wrong. So let me show you how you can save a little bit of time. You open up the network tab. In the network tab you have, let me refresh. You can set a filter. You can set a filter for images, and then you could even go and shrink a domain, or you can say priority. So you can filter it. I'm not sure if I know the filter settings here, but what I will do, I will also put in here large request rows, because then I can see here on the left side, or right side for you, a small image of the real image that is, it's just faster for me to understand which of those loaded images I look at. I can also click on that device thing here. I specify my pixel device ratio for the device that I want to debug. I can also specify a couple of dimensions here. I do responsive because I want to be able to resize my page. Yep, like this, you see. Okay, and these are a couple of settings that you can do that you reduce basically what you see here. I already, before I started, deleted all the other tabs. For me, very important is the name, the path, the status not so much, but the size and the priority. And those things I want to look at. Good, now that we have this, let me fetch the page again, and I jump to sources. I prepared a small script. It's called src. It's open sourced. I will link it later, but here I just hit the play button, and then I get asked with a very old dialogue. I'm not sure if you remember that dialogues back then. They used it a lot. It asked me like which element selector you want to use to target your image. I say image, very basic. Hit enter, and boom. Something in my page got colored red. So what you see here is the selected image that got a red border applied. I can hover, here I have logs. I see the device pixel ratio, and if I go down, I have the element reference. And if you see, if I hover over the node here, in the page, you see which element I'm looking at. It's pretty good to debug. And then you have a table, and the table tells me what breakpoint I am at the moment, or let's say what screen size I have at the moment, which source got loaded, which intrinsic size my image had, and which rendered size my image has. And here on the very, what is this for you? For you, it is the left side. On the very left side, you see the size difference. Is it undersized or oversized? And now look what happens when I resize my screen slowly. The red border gets smaller because the oversizing also gets less critical. And at some point, it goes from red to, no. Now here, you see a new entry. So I fetched a new image, and the image here is not 150 pixel wide, but 180. Let me zoom in a little bit more for you. And then I go on with this resizing, and you see it goes from red to blue in a dashed line, and it has a little bit more opacity. Now I know the pixel is the image is undersized. So now it's more undersized because it gets more transparent, and boom. I switch the image again, and I load a bigger image. And this process you can do until you're done, and you have all solutions. or resolutions, sorry. Yep. And then you have a table. You have a table on your left side that shows you exactly at which breakpoint, which source was loaded, if it was undersized, if it was oversized, and you always have a visual feedback, the red and blue border, and I can always hover here, and I can get more information. You see here I also see rendered sized, render aspect ratio, and all that stuff. So it's a tool just to figure out why your SRC set is not working. For me, it's the default case. It does not work, and then it takes me a couple of times to finally get it done. So I hope that is helpful for you. I collect all my performance snippets on a page. I will link it later. Let me show you why you should care about debugging that stuff. If you just put SRC set as I did and you don't really measure, maybe you make it worse. At least this is what I did. I just moved it in, it was correct, technically correct, and then I did a measure against my improvement, and it was not an improvement, it was a deprecation. So I basically fetched more data than before. It's not really good. So all the debugging, after we do it right, and I used my debugging tool and I figured out why in whatever's name it was wrong, I fix it. You see, I really made a significant impact. What I want to say is, read the docs, yes, but always measure. Don't guess, measure. The debugging tool is linked here. It's on GitHub on a repository. We call it Awesome Web Performance Snippets. I reference a couple of other of my colleagues there too, to give also credit to their snippets, and we try to collect stuff that is really helpful. It is stuff that you can execute in the console, stuff that you can execute in the sources tab. We have node scripts. We have a couple of plugins, Chrome plugins. Have a look if it is interesting for you. Next. This one is really wonderful. It applies to nearly any framework, React, Vue, whatever. Normally, if you don't think about it, your DOM structure, or we are in frameworks, your component structure is telling the browser when things should get fetched. What you see here on the screen is I need to fetch data for the side menu, and I need to fetch data for the image list. And I highlighted in the flame charts the time when the HTTP request is triggered. And if you can already guess what point I want to make, if your movie list is one of the last components in the app that got rendered, also your HTTP request is one of the last requests that get fired. And in this case, the movies is the stuff that you're really interested in. So you should not give the responsibility of data fetching to your component structure. React people know that very well, since longer than Angular people. I just want to point it out. It also applies to Angular. What I did, I just say, hey, my data fetching can be derived from something else already before. In my case, this was the URL. So I just look at the URL, and then I know which data I will use when my app bootstraps, and I just preload that data at the very beginning. When Angular bootstraps, I have this app initializer, snippets of code that will fire when your app bootstraps. And by doing this, I made a significant improvement. You can see the gray bars is what it was before. The pink, the color is called hot pink. The hot pink bars is the improvement. And it is drastically. You will not believe how much faster your app can get by just moving the requests to the beginning. And the code is minimum. The stuff that you saw before was basically the implementation. Wonderful. A last thing, in the last part of the browser render pipeline, it is about CSS. There's a really cool property, content visibility, and after everything was improved, we added content visibility to our website. This is a lab measure, so we basically scientifically tried to reproduce the impact, it's massive, and even on our page that was fully optimized, we went down from 160 milliseconds render time to 25 milliseconds, and from 30 milliseconds paint to 7. This is really like micro optimizations at the end, but we run that studies also on big real-life projects, and we can save up to a second with just a couple of lines of CSS. It's incredible. Please Google content visibility and contain, which is the older property, more supported property. After all of that stuff, and I have to speed up a little bit, I use web page test to make recurring measures. You see what we did from version 15 to 16.7, 16RC, then a couple of improvements that I mentioned. We really significantly improved the largest contentful paint, and this is not milliseconds, but this is in the range of seconds, so decent. Now, I'm not sure how many people were here yesterday. I hope a lot of you. As you are an Angular-heavy crowd, maybe you missed a wonderful talk that also scratches the surface of INP. I will talk about INP in Angular from version 12 on. Yesterday, Ashima did a talk about the React implementation of it, React concurrent mode, and he showed a lot of similar things that I will show you just in another framework. So it's pretty cool that frameworks work very similar nowadays, and we share knowledge. So let me quickly show you what you can do. This is the bootstrap phase. Normally bootstrap phase is outside of INP, but in practice people do unexpected things, and if somebody touches your screen while you bootstrap your app, you have a bad INP. So this is the bootstrap phase, and whenever I tell people, look at your bootstrap phase and try to optimize it, they tell me it's not possible, we tried everything. And then I try it again, and there is always something you can land. So let me show you what you can land in Angular. You analyze your bootstrap phase, you realize there is something related to Webpack, very hard to optimize, and then you have 3 phases in Angular: Angular Bootstrap, Angular Initializers, and Angular Routers. And I showed you already the initializer where I did the data fetching. Let me show you another trick here. After I'm done with my optimization, I did basically 3 things. You have now, instead of one massive task, 4 to 5 different tasks visible here. The color of all the tasks is gray, not red anymore, and this is a good sign without going too much in detail on the flame charts. But what I did is I scheduled all those steps with a very primitive scheduler. I just wrapped them with a set timeout or anything else that is not a promise. And then you will see that the bootstrap time gets chunked out of the Webpack part. Then app initializers, I also wrapped it with a set timeout. It got chunked out of the bootstrap phase. And then the routing, I also initialized with an asynchronous scheduling, and it also got chunked out. So now we have a nearly perfect bootstrap phase. And the only stuff that was missing back then was the size of my JavaScript and the Webpack bundle part, bootstrap part. Nowadays, in the next version of Angular especially, this is also solved. Just install it, it's gone. Not a lot of people know you also can use zone flags. This is a real customer project, massive scale. Not sure if you know the customer, but this one I believe is from ClickUp. They booked us for quite a while to optimize their performance. And at the top you see native Angular. I added 3 lines of code just to unpatch a couple of APIs. In this case, let me check a timeout, set interval, scrolling events, and any type of request. I unpatched, and boom, all the red flags and triangles are gone, and it was a massive, massive improvement. You want to use it? I published a couple of blog posts on that. I always have an open source library where you can download the code, install the code, use it for free every time, MIT license. Read it up, try it out, maybe it helps you. Zoneless. At some point in the future, Angular will be able to run zoneless. For everybody that does not use Angular, we in the Angular community, we have a very weird way of detecting our changes. We have an implicit change detection. Eh? So you never ever write something about set state or use this effect and this and this. So you just write code and it boom works out of the magic box. And this is not really good for bigger projects and very good for small projects. And over the year, the whole community agreed that we should really get rid of that zone stuff. So in maybe a year or so, I don't know, we will be able to drop zone completely from Angular. It was a passionate problem. I was really passionate for this problem to solve it. And I guess 4 years ago, we shipped an open source library, the one that I mentioned before, RX Angular, that basically made Angular zoneless and fine-grained, like all the fancy hyped terms that you use nowadays, fine-grained reactive change detection. We basically shipped that 4 years ago. And it's very easy to implement. You just remove the zone configuration, you move the import, and you use our library in the template. At the moment, model-based only. Good. If you have it installed, you can tweak a little bit how things work in your framework. And you can replace a couple of building blocks, especially when you have bad navigation. I believe you have somewhere a list in your code base, and your lists are most probably the first thing that I would fix. So we have a couple of directives. One of the directives is called RX4. It accepts a static array, a promise that returns an array, or an observable that returns an array. And then it will do something very cool and interesting. And now I get back to Ashima's talk from yesterday. So all the highlighted boxes, yellow boxes that you see at the bottom are updates, change updates. And they all happen in the same browser task. This is the gray box at the top. And if you see the left side of the gray box, it is red. That means it has some overtime. At the moment, the browser considers 50 milliseconds as okay-ish long. Everything above that 50 milliseconds is not really good, and you should optimize it. Problem is, it's very hard to optimize that stuff. It's nearly impossible to optimize this list rendering in Angular in a very smart way. So we wrote a lot of code, then we figured out that React did the same under the hood. Then we made a comparison, and then we figured out, man, React is so much better. So we dropped our code, we installed the scheduler from React, and now we are able to integrate that in a very nice way, a little bit better even than React did it. Yeah, it's true. We process any type of work as long as we don't reach 50 milliseconds. If we are close to 50 milliseconds, we stop processing, schedule that stuff in a new task, and start again. So you can flood your main thread with as much work as you want, and the scheduling techniques that we use will make sure that you never produce a long task again. Beautiful. I have 10 minutes left. How did we do that? Task prioritization. This is a little bit of a repetition from Ashima's talk yesterday, but let me quickly walk you through the building blocks. There is this priority. We had the priority already with HTTP requests. Now we have a priority that lives in the main thread. And this is basically which block of work you execute first and which block of work you execute later. And with a couple of APIs, you can schedule a task and change the priority. Or you can schedule the task and optimize the timing. And we used a couple of different techniques. In the end, we settled with, in old browsers, it's a patch. We have 6 priorities. In modern browsers, you could use post-task schedulers, really cool and fancy things. And then we do the following. So you give us your work packages. Every work package has a priority here from 1 to 5 numbered. Then the mechanism will sort your work, and then the mechanism will execute your work, and everything with priority 1 will go first, and then 2, and then 3, and then you can get it. The point. Little bit more details. If you want to read out all the details, check out our open source repository. But this is how you can code. You can basically, if you like, right, even say, aha, this is a tooltip. I'm pretty sure this is important for the user, because if I hover over something and the tooltip takes just 25 milliseconds, I'm already convinced that the website is slow, right? Tooltips, they have to be there as soon as the mouse touches the box. Then you have other things that can be slower, and then you have HTTP requests, background synchronizations. It's not visible to the user. The user will never feel when you send out your HTTP request, so you can down prioritize those things as much as possible. Let me speed up. With prioritization, I can even do an incredible cool thing, and this is only possible in Angular at the moment. I can tell my DOM structure, I don't care how you look, I want you to render in a different order. So I can say my largest content full paint lives in the image list and not in the menu, so please start with the image list and then do the menu. Even if your DOM structure or component structure tells the opposite. You just put a priority there, under the hood the scheduler will do it for you. Really cool. We also worked on virtual scrolling. Any framework has a virtual scrolling implementation. Any implementation is slow. We spent a decent amount of time to analyze this. There are a couple of really good blog posts von Das Surma. So we digged in and we wrote our own virtual scrolling for Angular. We compared it, of course, with the Angular implementation. We are 16 times faster than the Angular implementation. It's again open source. It is again living in this RX Angular repository, and it is a drop-in replacement to the Angular CDK. Same API, same token, same wording. Check it out. Yeah, this was an experimental release, and we got, I guess, one very good feedback, and the next version will be fully stable. Here's the link to the repository if you like it. And we can recap. We started with a very slow implementation. We ended with a pretty decent implementation. And most of the things are not that hard to optimize and not that hard to understand. I believe if you follow a couple of the things that I showed you today, you will make already a decent improvement. And for all the rest, DM me on Twitter or somewhere else, or shoot me an email, and I will help you to figure out the rest. I love to fix these problems, and the more I can fix, the better my life is. So don't hesitate and contact me. Again, to remember the 3 different frameworks, at the moment Angular is the fastest, and I'm looking for somebody that helps me with Next and also applies the same styling and visual appearance to the Next implementation than we have in React and Angular, and then the comparison is maybe even more fair. Good. That's it, I guess. I talked about server-side rendering, image optimization, bootstrap time, zoneless, virtual scrolling, CSS improvements, a lot of stuff. For nearly all of that improvements, I have a complete talk somewhere else. Google my name plus CSS improvement or my name plus server-side rendering. You will find something for that. And I want to point out for all that stuff that we open sourced, we got funded by the Chrome funding framework. It's pretty cool. I was extremely happy. This is the library where we move most of our Angular-related performance things in. All the other snippets are in other repositories. Check them out. Thank you a lot for your time. If you need help with performance on a professional level, we do that as a consulting service. Reach out to our website, check out what we do. Maybe you need it for your company. If not, contact me privately and I fix the problems anyway. And that's it. Have a good day and thanks for your time.